formula a couple more times just in case you weren't as excited about it. We'll get you all warmed up. And what I want you to know, you will sometimes get decimals. A good rule of thumb is to round to the nearest tenth in these problems, unless you're told otherwise. But for now, just assume to round to the nearest tenth, or to leave them as fractions, which is what I will probably do. So we've got our equation, 3x squared plus 5x minus 12. It's equal to 0. That's good. It's in standard form. So now I just identify my a, b, and c. A is 3, b is 5, c is negative 12, and we're all ready to go right to our formula, which is, I'll write it off to the side, minus b plus or minus the square root of b squared minus 4ac all over 2a. So now I'm going to start plugging numbers in. Minus b is 5, plus or minus the square root of b, which is 5, squared, minus 4, times a, which is 3, times c, which is negative 12, all over 2 times a, which is 3. So I get negative 5 plus or minus the square root of 25. I get negative 4 times 3 is negative 12. Negative 12 times negative 12 is plus 144. Just simplifying those terms in there. 2 times 3 gives me 6, which means I get negative 5 plus or minus the square root of 25 plus 144 is 169 over 6. And the square root of 169 is 13. So I get negative 5 plus or minus 13 all over 6, which means I'm going to have two different answers. I'm going to have negative x equals negative 5 plus 13 over 6. And I'm going to have x equals negative 5 minus 13 over 6. Well, negative 5 plus 13 would give me 8 over 6, which simplifies down into 4/3. There's one of my answers. Negative 5 minus 13 is negative 18 all over 6. Negative 18 over 6 is negative 3. There's my other answers. So your answers would be 4/3 and negative 3. If you wanted this 4/3 as a decimal, it would be 1.3 repeating. So if you rounded to the nearest tenth, you would get 1.3. Again, just using the formula. Looking at the second one, it's not already in standard form, so I have to subtract 25 from each side. So I get 10x squared minus 5x minus 25 equals 0. And I've got my a is 10, b is negative 5, c is negative 25. And I can just plug them right into my formula. Minus b is negative 5, plus or minus the square root of negative 5 squared minus 4 times a times c all over 2 times a, 2 times 10. So now minus negative 5 is positive 5, plus or minus the square root of negative 5 squared is 25, minus 4 times 10 is negative 40, times 25 is plus 1,000. All over 2 times 10 is 20. So I get 5 plus or minus the square root of 1,025 all over 20. And notice in this step, we're going to do something a little different. Because 1,025 is not a perfect square. If you take the square root of 1,025, you get 32.01562,119. You get a really weird decimal. I don't need you to write out that 32.0156 if you don't want to. You can just write it like this. You take it at this point and you split it into your two answers. You do 5 plus the square root of 1,025 all over 20, and you equals x, and you do 5 minus the square root of 1,025 over 20 equals x. This is showing me your work, and then you can just give me the decimals. And the decimals would be about 1.9 equals x, when you add it, and you would get about negative 1.4 when you subtract it, and those would be your two answers. I don't need you to show me that long written out decimal. Just leave it as a square root to save yourself a little bit of work. But again, just using the quadratic formula, sometimes you'll get decimals, sometimes you'll get whole numbers. Just depends on what the equation is. There's not really a great rule to know whether you're going to get decimals or not. Just understand you very well can get decimals.